We gaze at photographs, mesmerized by moments frozen in time. But have you ever wondered about the magic that transmutes light into these tangible memories? It's a captivating tale of science, where photons dance with silver halides, etching stories onto light-sensitive surfaces. This is the realm of photochemistry, the backbone of photography. At its heart, photography is about capturing light. Light, composed of massless particles called photons, carries energy. When these photons strike a light-sensitive material, they initiate a chain of chemical reactions. These reactions alter the material, leaving behind a latent image, an invisible imprint of the scene witnessed by the lens. Imagine a canvas primed not with paint but with chemicals yearning for light's touch. Each photon, like a brushstroke, leaves its mark, cumulatively painting a picture hidden from our immediate view. This latent image, a chemical whisper of the scene, awaits further processing to reveal its secrets. This intricate interplay of light and chemistry forms the bedrock of photography. Silver halides, the key players in this process, are compounds of silver with halogens like bromine, chlorine, or iodine. When exposed to light, these silver halides undergo a transformation, breaking down into elemental silver and halogen atoms. In the darkroom, developers reduce the exposed silver halides to metallic silver, making the latent image visible. Fixing agents then remove any unexposed silver halides, stabilizing the image and making it permanent. Understanding this fundamental principle unlocks the door to comprehending the entire photographic process, from the initial click of the shutter to the final, cherished print. The key to this magical transformation lies in a class of compounds called silver halides. These light-sensitive chemicals, typically silver bromide, AgBr, or silver chloride, AgCl, are embedded in a gelatin matrix and coated onto a substrate, forming the photographic emulsion. Silver halides possess a unique property. They are highly reactive to light. When a photon strikes a silver halide crystal, it dislodges an electron, creating a free electron within the crystal lattice. This electron, now energized and restless, seeks stability. Enter the silver ion, Ag+, residing within the same crystal. The free electron, drawn to the positively charged silver ion, combines with it, forming a neutral silver atom, Ag. This process, known as the latent image formation, is the crux of photographic capture. These minute silver atoms, clustered together in the areas exposed to light, form the invisible latent image. The more light a region receives, the more silver atoms form, creating a chemical map of the varying light intensities that painted the original scene. Exposure, the pivotal act of capturing light, marks the beginning of the photographic process. It's the moment when the camera lens, acting as a gatekeeper, allows light to interact with the light-sensitive surface for a precisely controlled duration. During exposure, photons stream through the lens and bombard the silver halide crystals embedded in the emulsion. Each photon, carrying a quantum of energy, has the potential to liberate an electron within a silver halide crystal, initiating the latent image formation. The amount of light allowed to reach the film or sensor, determined by the aperture and shutter speed, dictates the extent of latent image formation. A larger aperture and a slower shutter speed permit more light, creating a brighter image, while a smaller aperture and a faster shutter speed restrict light, resulting in a darker image. This delicate balance of light and time, meticulously controlled by the photographer, determines the overall exposure of the image, laying the foundation for the subsequent chemical processes that will reveal the hidden picture. The exposed film, harboring the invisible latent image, enters the magical realm of the darkroom. Here, bathed in the dim glow of safe lights, the latent image transforms into a visible one through the alchemy of chemical development. The developer, a carefully concocted chemical solution, acts as a catalyst, amplifying the latent image. It selectively reduces the silver halide crystals that have been exposed to light, converting them into pure metallic silver. This metallic silver, dark and opaque, forms the visible image. The developer's magic lies in its ability to differentiate between exposed and unexposed silver halide crystals. It preferentially targets the crystals containing latent image specks, clusters of silver atoms formed during exposure, and leaves the unexposed crystals largely untouched. This selective reduction process, governed by chemical kinetics and thermodynamics, amplifies the faint imprint of the latent image, transforming it into a visible negative or positive image, depending on the type of photographic process used. The development process, though essential for revealing the image, must be carefully controlled and halted at the right moment. Left unchecked, the developer would continue to reduce silver halide crystals, eventually leading to an entirely black image. This is where the stop bath comes in. This acidic solution, typically a dilute solution of acetic acid, serves as the brakes in the photographic process, effectively halting the development reaction. It neutralizes the alkalinity of the developer, rendering it inactive. The stop bath's role is crucial in preventing overdevelopment, which would result in a loss of image detail and contrast. By precisely controlling the duration of the stop bath, photographers ensure that the development process is halted at the optimal point, preserving the integrity of the image. This careful balancing act, stopping the development at the precise moment, highlights the delicate nature of photochemistry and the importance of understanding the chemical processes at play. After stopping the development, the photographic material still contains undeveloped silver halide crystals. These crystals, if left untreated, would continue to react with light, causing the image to darken and degrade over time. To prevent this, the image undergoes a crucial step called fixing. The fixer, typically a solution containing sodium thiosulfate, Na2S2O3, dissolves the remaining undeveloped silver halide crystals, rendering them insensitive to light. The fixer works by converting the insoluble silver halides into soluble silver thiosulfate complexes, which can then be easily washed away. This process ensures that the image remains stable and light-proof, preserving it for posterity. Without fixing, the photograph would be fleeting, gradually fading and degrading with continued exposure to light. The fixer, therefore, plays a vital role in ensuring the longevity and permanence of the captured image. The final step in the photographic process involves thoroughly washing the print or negative to remove any residual chemicals, particularly the fixer solution and its byproducts. These chemicals, if left behind, can degrade the image over time, causing staining and fading. Washing involves immersing the photographic material in fresh, running water for an extended period. The water dissolves and carries away any remaining soluble chemicals, leaving behind a clean and chemically stable image. Proper washing is crucial for the long-term preservation of photographs. Residual chemicals can lead to a slow but steady deterioration of the image, diminishing its quality and archival stability. By diligently washing away the remnants of the chemical processes, photographers safeguard their images, ensuring that they endure as testament to moments captured in time. Photography, far from being a simple act of pointing and shooting, is a delicate dance between art and science. It relies on a deep understanding of light, optics, and the intricate chemical reactions that underpin the image-making process. Each step in the photographic process, from exposure to washing, involves a carefully orchestrated series of chemical reactions. These reactions, influenced by factors like temperature, time, and chemical concentration, must be meticulously controlled to achieve predictable and desirable results. Mastering photography, therefore, involves more than just artistic vision. It demands a firm grasp of the underlying scientific principles. Photographers who understand the chemistry of photography are better equipped to control the image-making process, pushing the boundaries of creativity and technical excellence. This harmonious blend of artistic expression and scientific precision is what elevates photography from mere image capture to a captivating art form. Understanding the chemistry of photography empowers photographers with the knowledge to manipulate the image-making process, achieving specific aesthetic effects. By adjusting factors like developer type, development time, and chemical concentrations, they can fine-tune the contrast, grain structure, and overall tonality of their images. For instance, using a high-contrast developer can result in images with stark blacks and whites, while a low-contrast developer yields a softer, more nuanced tonal range. Similarly, extending the development time can increase image contrast and grain size, while reducing it can create a softer, lower contrast look. This ability to manipulate the chemical processes allows photographers to imprint their artistic vision onto the final image, transforming it from a mere recording of reality into a unique and expressive work of art. By understanding the chemical tools at their disposal, photographers unlock a world of creative possibilities, expanding their artistic vocabulary and pushing the boundaries of photographic expression. In today's digital age, where images are captured and shared instantaneously, the allure of chemical photography persists. The tangible nature of the process, the physical transformation of light into image, holds a certain magic that digital photography cannot replicate. The darkroom has become a sanctuary for many photographers, a place for experimentation and contemplation. Chemical photography continues to captivate both professionals and amateurs. It stands as a testament to the enduring power of light and chemistry. Let us remember the intricate dance of photons and silver halides, and the alchemy that transforms light into memory. The enduring legacy of chemical photography.